Okay, so now we're going to do table 2. So remember, what we're trying to do is we're trying to find the rate law for the experiment. The rate is equal to the rate constant K times the concentration of each reactant multiplied together, but then you raise them um, to some exponent. Typically, the exponents are 1 or 2, somewhere 1 or 2. So we're going to do that for peroxide, hydrogen peroxide, and we're going to do that for potassium iodide. The exponents, we'll just call them X and Y for now. So we're going to use, for concentrations, we're going to use the initial concentrations. So the initial concentrations is calculated in table 2. We begin by noting that in order to find concentrations, we need to know the total volume of the solution in liters. So the way we go about that is we add up all the individual volumes. So remember, for experiment 1, we added all these together. And if you calculate it, so I'm just going to hit equal sign sum. If you calculate this volume, you get 500 milliliters. So if you try it for the second one, for the second experiment, okay, see what I did? Equal sign sum for adding them all up. And then I just clicked on all the cells and put that in parentheses. You also get 500. Now, you don't have to do it each time. You can just go down and it'll automatically know to do each row. Okay. 500 milliliters was the total volume. Okay. So now we come over here and we put in 500 ml. To calculate that into liters so that we can do molarity calculations, we do equal sign volume in milliliters divided by 1,000. Okay. Divide the volume in milliliters by 1,000, and that'll give you liters because there's 1,000 milliliters in 1 liter. So 0.50. So now what about the initial moles of Ki, initial moles of Na2S2O3, and initial moles of H2O2? Those, we have them already. So what I'm going to do is I'm going to just take the data from table 1 and put it right into here. So I'm going to come up to the first initial moles of Ki and hit equal sign. That tells me that it tells the program that we're going to do some sort of calculation. And I'm going to come over here to chart 1 or to table 1 and hit this cell right there, moles of Ki, because that's the number we're trying to find. Hit enter and it automatically did it. And again, it's smart enough that if you then just come down, it will actually go to the next cell in the previous table. Just make sure you hit equal sign so that it knows, oh, we're going to actually take some data from a previous table. Now, to find the initial concentration is just moles over liters. So equal sign moles divided by liters. And here's our liters, 0.5. Now, here you have to be a little bit careful. I'm going to hit that right there and then hit enter, and it did the calculation. That's fine. The problem is that when we try to come down now, it's going to automatically try to keep going down. It's going to think there's a pattern. So the way we say no, for every one of these we want to divide by 0.5 is we could do instead of equal sign B8 over cell H5, we could just divide by 0.5. But another maybe more elegant way to do it is to put dollar sign in front of the H and dollar sign in front of the 5. What that does is it tells the software that if we do any further calculations with this, like we're going to do in this column, always use H5. Don't go to H6 and then H7 and then H8. Just do H5. Okay? Then you can do your autofill and it'll give you the right numbers right there. So notice what it's going to do each time, it's going to keep it H5. And the way you get that is by putting in dollar sign H, dollar sign 5. If you just put H5, it'll go down to the next cell to do the next calculation. We're going to do the same thing for the sodium thiosulfate. So equal sign, initial moles. Here we go, moles. Hit enter. And then again, we can just come on down, put those in there. Notice that doesn't change. The reason it doesn't change is because we're using the same amount of sodium thiosulfate each time. Okay. And again, we're going to take this, divide it by that volume right there. But again, I'm going to put my dollar signs in there. And then now I can just come down. Okay. That's going to be the same. Peroxide will have 3 that are the same and 2 that are different. So equal sign, initial moles. We come over to table 1. Here we go, moles, 0.005 for the first one. And then we can come on down. Okay. So notice it's the same for the first 3 experiments, and then it gets bigger. Equal sign, initial moles divided by total volume. But again, we're going to do this multiple times. So we do want to have a fixed value for the volume. Okay. So now we have the initial concentrations of the 3 important reagents that we're going to need for our calculations. So the initial concentration of potassium iodide, it changes from experiment to experiment 3, then it stays the same. The concentration, the initial concentration of sodium thiosulfate remains the same each time, and the initial concentration of H2O2 changes for each experiment. Now, you only probably did 2 of these 5 experiments, so you would have had the numbers for those 2 experiments, but again, we're pooling all of our data, so now you have it for all 5. So we're going to next, in table 3, we're going to look at how these initial concentrations can then be used to find the rate law.